Problem 11. A particle has position given by the equation x of t equals 5t cubed minus 3t squared plus 7. What is the acceleration of the particle at t equals 3? All right, I'm at position right now. There we go. I'm at position right now, and I want to get to the acceleration. So first of all, to get from position to velocity, I'm going to take the derivative of position, and when I do that, I will get 15t squared minus 6t. And then to get to the acceleration, it's the derivative of velocity, and that is going to be 30t minus 6, and I would like the acceleration at 3. So if I plug in 3 here, I will end up getting 90 minus 6, which is 84. Right, number 12, an uninsulated cup of coffee cools from 185 degrees to 150 degrees exactly 4 minutes after it is served. Assuming the coffee shop maintains a constant temperature of 75 degrees, how much additional time will it take for the coffee to cool to 95 degrees Celsius? I do notice that this is a cooling problem, so we're going to use Newton's law of cooling, which states that the temperature of the object is equal to CE to the KT plus the temperature of the medium. Alrighty, I do know that the temperature started at 185, so I'm going to put 185 equals CE to the K times 0, plus the temperature of the medium would be how cool the coffee shop is, which is 75. Okay, to get C, I'm going to subtract 75 from both sides, and when I do that, I will get 110 equals C, because K times 0 is 0, e to the 0 is 1. So I know that C is equal to 110. Okay, my next thing that I'm going to do is the temperature of the object is now equal to 110 e to the KT plus 75. The 75 gets to stay forever in this problem. The next thing I know, it cooled to 150 after 4 minutes. So the temperature of the object is 150 after 4 minutes. So 4K plus 75. I'm now going to solve for K. So I'll subtract 75. And when I do that, I'll get 75 equals 110 e to the 4K. I will next divide by 110, and when I do that, I will get 75 over 110 is equal to e to the 4k. I'll now take the natural log of both sides, so I'll have the natural log of 75 over 110 is equal to 4k ln e, and the natural log of e is just 1. And then to get k by itself, I'll just divide by 4, so k will equal the natural log of 75 over 110, all divided by 4. Okay, so my new formula now is the temperature of the object is equal to 110 e to the, not k anymore, e to the ln 75 over 110, all divided by 4, t plus 75. Okay, and we want to know how much additional time it will take for the coffee to cool to 95. So now I want the temperature of my object to be 95. So if 95 equals 110, e to the ln 75 over 110, t over 4 plus 75. Now I'm going to subtract 75 from both sides, so I'll get 20 equals 110 e to the natural log 75 over 110 all over 4t. Next thing I'm going to do is divide by 110, and when I do that, 20 divided by 110 would reduce to 2/11ths. You don't have to do that, but you may. So I'm just rewriting what I have here. Okay, and then from here, I will do the natural log of both sides. So I will get the natural log of 2/11ths equals, if I do the ln e, I will end up getting ln of 75 over 110 all over 4t. And then to solve for t, I could either divide both sides by this, or actually I prefer to multiply by the reciprocal of it. There are just less parentheses that I need to deal with, so I'll multiply this side also by 4 over the natural log of 75 over 110. And when I do that, I will get that my time is equal to 17.805, but that's the total time it's going to take to cool. This says how much additional time is it going to take. It has already cooled for 4 minutes, so if I subtract 4, I will get 13.805 minutes. Okay, question 13. Given that f of x has a relative maximum at x equals -2 and a relative maximum at x equals 0, choose the correct statement. So if I see a word about relative minimum and relative maximum, I know that has to do with f prime. So I'm going to make an f prime chart. And if things are happening at -2 and 0, I'm going to put -2 and 0 on my chart. If there's a relative minimum at x equals -2, that means that f prime must change from negative to positive. And if there's a maximum at x equals 0, f prime must change from positive to negative there. So if I look at my choices, is f prime positive from -2 to 0? Yes, that would work, but I'm just going to verify. Oh, we're gonna go back to that one. That looks like a possible choice, but actually it is not, and I'll discuss it in a minute. F prime is negative on the interval -2 to 0. That's not true for sure. F prime is negative on the intervals -pi to negative infinity to -2 and 0 to infinity. That's definitely true. And f prime is positive on those same intervals, and that is not true. Okay, so now we see choice A and choice C. Kind of it looks like they both give me the right answer. The catch on part A is there are brackets on this one, and actually we shouldn't use brackets because at 0 we would know that the derivative is equal to 0, so it would not be positive. So A can't be a choice, so actually C is my choice for this problem. A little tricky. Okay, 14. Consider a particle whose motion is represented by the position equation. At what value of t does the particle change direction? If a particle changes direction, the velocity is going to change signs. Okay, so what we need to do is find the velocity and see where it might change signs. So if this is my position, my velocity is going to equal the derivative of the position, which is going to be 3t squared minus 4t plus 1. And to find where it changes signs, I first of all need to figure out where does that equal 0. And I'm going to use the magic number trick on this. So if you don't know how to do it, follow right along. I do know I'm going to have to divide out my 3 when I'm done. 3 times 1 is 3. -3 times -1, 3 times 1, -3 plus -1, it gives me -4 in the middle. And then I do need to divide the 3 out of one of those parts, and I'm going to divide it out of this one, so it will be t minus 1, and then 3t minus 1 equals 0. And then if I set each of these equal to 0, this would be t equals 1, and then this one is going to be t equals 1/3. So from here, just because I got those, that doesn't mean that's where it changes direction. We need to verify it. So I'm going to make a velocity chart. Notice it's not an f prime chart, it's a velocity chart. I'm going to put 1/3 on it, and I'm also going to put 1 on it. And if I work that out, if I plug in 0 for velocity, I'll get a positive answer. If I plug in 2/3 maybe, or 1/2, I'll get a negative for my velocity. And if I plug in something bigger than 1, such as 2, I'll get a positive answer. So when it says at what values of t does a particle change direction, it does indeed change direction at t equal 1 and t equal 1/3. But we did have to check it because it was possible that it didn't change sign at those values. Okay. 15, find y prime if y equals x squared plus 2x to the 4th. Okay, this one, we're taking the derivative. I do notice I have parentheses, so I'm actually going to do a chain rule problem on this one. So we're going to do a u substitution, and I'm going to call this u to the 4th. So if I take the derivative of u to the 4th, it's going to be 4u cubed times the derivative of the inside, times the chocolate. So the derivative of the inside is 2x plus 2. And now I'm just going to rewrite what I have. It's going to be 4 excuse me, x squared plus 2x to the 3rd times 2x plus 2. And let's see if that matches any of them. It kind of looks like it's matching closest to C, and I guess I could verify that. I believe they just, to get that answer, they distributed the 4 into both sides, so I'd get x squared plus 2x to the 3rd power times 8x plus 8. So indeed, it would be choice C. At what value, for 16, does the function have a horizontal tangent line? Okay, if something has a horizontal tangent line, it would have a slope of 0. So in our case, we will have a derivative equal to 0. So we're going to find out, where does this derivative equal 0? So the first thing that I need to do is take the derivative. I do know that the derivative of the ln is just du over u. I don't care about the absolute value signs on this one. So my derivative is going to be du, which would be 2x, over u, which is x squared plus 2. And then I just need to decide where would that derivative equal 0. Well, I know if I have a fraction, the fraction will equal 0 when the numerator is equal to 0. So I'm just going to take 2x equals 0 and solve for x. And when I do, I get at the value at x equals 0. Okay, problem 17. Find the integral from 0 to 2 of x squared plus 1 squared. Okay, you might be thinking, let's do a u substitution on this one, but your du would not be there. So probably the easiest way to do this one would actually to be expanding it. So I'm going to have x squared plus 1 times x squared plus 1. And when I do that, when I FOIL it out, I'm going to get x squared plus 2, whoops, x to the 4th actually, plus 2x squared plus 1. And now since there's a plus sign, we can go ahead and separate it into 3 separate integrals. And now from here, we're going to go ahead and take the integral of each part. So I'm going to have 1/5 x to the 5th plus 2/3 x cubed plus x. And I don't need to put plus c because I'm actually going to evaluate it, and I'll evaluate it at 0 and 2. If I plug in 2, I'll get 32/5. If I plug in 2 here, I'll get 16/3. If I plug 2 in here, I'll get 2. And then minus, if I plug 0 in, I'll just get 0. So from here, I'm going to get a common denominator. So I'll get 96/15 plus 80/15 plus 30/15. And when I figure that all out, it will be 206/15, which gives me option B. Okay, problem 18. Find the integral of the tangent to the 5th x secant squared x dx. We don't have a formula for anything that looks like this, but what I'm going to do is do a u substitution. I'm going to let u equal the tangent of x. If I do that, du, the derivative of tangent, hopefully you already know this, is the secant squared x dx. And if you'll notice, the secant squared x dx is sitting right in my problem. So if I go to substitute in what I just did, I let the tangent of x be my u. I did nothing to the 5th power, so it's going to be u to the 5th, and then everything else is going to turn into du. And then from here, I just increase my power by 1, so I'll have 1/6 u to the 6th, and then from here, I just plug my u back into my problem, and then I have the right answer, and looking at that, that will definitely be choice D. All right, problem 19. Find the integral of the natural log of the square root of x over x dx. Whenever we have an ln in our problem, that has to be the u. So we're going to let u equal ln square root x. All right, when I go to find du, though, before I do anything with this, I'm going to rewrite this as ln x to the 1/2 power. And then hopefully you remember that we're allowed to put the 1/2 out front. So this is actually going to be 1/2 ln x. And then when I go to find the derivative of ln, remember, is just du over u. So that 1/2 is just going to carry out with me. And then my u is my x, so this is just going to be 1 over x. So this actually will just be 1 over 2x dx. So if I'm looking at this problem, the x is down in the bottom just where it's supposed to be, but I do also need to put a 1 there. And really that was like introducing a 1/2 to the problem. So on the outside, I do need to undo it with a 2. So now this is going to be 2. I took the whole ln squared of x to be my u, and everything else turned into my du. And so from here, I'm just going to use my power rule, which is, right now the power is 1, so I'll increase my power by 1, so it'll be u squared, and it'll be 1/2 u squared, times the 2 that's already sitting out there, so that will just end up being u squared. And if I plug my u back in, my u was the natural log of the square root of x squared plus c, which is choice C. Okay, problem 20, the integral of x e to the x squared. Whenever I have one e in my problem, I will always let u be the exponent. So we'll let u equal x squared. And then my du will be 2x dx. I notice that I have an x, I'm just missing a 2. So I'll put a 1/2 on the outside to undo that. So I'll have 1/2. In my problem, I have done absolutely nothing with the e, so the e is still there. And I'll be e to the u, and everything else turned into du. And then hopefully you remember that the integral of e to the u is just e to the u. And my 1/2 just kind of tags along. And then all I need to do is replace my u back with what it was, which was x squared plus c. And then the problem that should match is choice C.